Let's see this beautiful example of a factorial equation. A factorial, b factorial equals to a factorial plus b factorial plus c factorial. Solution obviously is ABC, ABC, and DAC because for symmetry. So let's start to consider some cases. A equal to 0 and a equal to 1 brings both to b factorial equal to 1 plus b factorial plus c factorial. That is 0 equal to 1 plus c factorial. That obviously is not a solution because it's simple to see. The case a equal to 2 brings 2b factorial equals to 2 plus b factorial plus c factorial, and this brings to this equation, but obviously, why obviously? Because the difference between 1 to 6, the top factorials of b and c, increases. So we cannot have solution in this case. If you want to see in another way, I've written here that between a and b there is not much difference, so we can confuse b with a, and with no loss of generality we can obtain a greater or equal of 3. So go to the case equal to 3 to verify this sentence, and is verified because 6b factorial is equal to 6 plus b factorial plus c factorial, and this equation is solvable. We cannot know the solution, but it's solvable, and that's enough. So let's start to analyze our case, that is b factorial equal to, I divide obviously here 1 to 1 plus b factorial, a factorial plus c factorial on a factorial, and we can suppose without loss of generality that b is greater than a, greater or equal than a. Why we can suppose it? Obviously for the symmetry of the solution, because b is symmetric, and you can substitute without losing any solution. So we have that a is greater than 3 because of the first sentence we achieve, and for supposition is into this interval from 3 to b. Okay, but let's now consider this, because factorial plus b factorial plus c factorial is less or equal than b factorial plus b factorial plus b factorial. That is less or equal than b factorial. Okay. At the same time, this is the greater or equal than 3b factorial equal to 6b factorial, because we've seen this in the case above. Okay, so this is impossible. It's not possible that the same quantity is less than 3b factorial and greater than 6b factorial. And so we have achieved that 3 is less than that is less b that is less strictly than 2. Okay, so this is the first case, not the first case, the first block. Let's suppose now that a is different from b, and we notice that the left hand side is even and the right hand side is even, because if the right hand side is even, obviously also the right hand side that is equal is even. But so, referring to this, c is greater than a plus 2. Why? Because c is strictly greater than a b. So it's plus 2. But now we can state that c factorial and a factorial is even. Why is even? Because a plus 2 for a plus 1 for a contains at least one even terms. Even term because two integer multiplied near two near integer multiplied between them becomes even fact. But so if the right hand side is even, p factorial and a factorial is odd because there is one here, 1 plus b factorial and a factorial, that this way necessarily b factorial and a factorial is odd. But so is equal to b plus 1 necessary. Y equal to b plus 1 because if we have been b plus 2, there is a terms on b plus 2, b plus 1, b that contains a factor of the product of two factors that so is even. Okay, so let's go here. B factorial is equal to 1 plus b factorial and factorial plus c factorial. So let's go to substitute. B plus 1 equal. Sorry, there's an error here. It's not. B plus 1 is a plus 1 equal to b. Okay, sorry. So we can substitute a plus 1 to this, and we can obtain this equation. This equation we can obviously divisible. This equation is obviously divisible by a plus 1, and we can do this, obtain this, and we see that a plus 1 on a plus 1, it gives an integer like this. So this is an integer and this must be an integer. So a plus 1 must be equal to 1. So a equal to 0. Okay. So if a equal to 0, this means that a is not equal to b, because a equal to 0 gives no solution. And so we have the second break of this big problem. It is that a equal to b is between 3 and c. Between 3 is 3, not strictly, and between c strictly. Okay, so we can change and we can arrive to our solution, that is a factorial equal to a factorial plus a factorial plus c factorial, a factorial equal to 1 plus 1 plus c factorial, and a factorial 2 equal to c factorial, a factorial, and this. Why we have made this? Because we have state that a equal to b, so I write here equal to b. We are substituting into the original equation. So let's consider a factorial less minus 2. Sorry, a factorial minus 2 not divisible by 3 because 1 is less. is greater than 3. So 3 divide C factorial. And so C is R plus 4. So C is equal to R plus 2, and C is equal to R plus 1. Let's go to substitute. Allora, R factorial on R quadro R, and this is obviously R equal to 4. C equal to R plus 1. Now we go to substitute. R factorial, let's do, equal to C factorial, and R factorial. So R equal to 3 on R equal to 3, and so we obtain finally that R factorial B factorial equal to R plus B plus G. That is 3 factorial equal to 3 factorial 3 factorial plus 4 factorial, and this is finally our solution of this beautiful and difficult exercise on factorial equation. Let's see to the next video. Bye bye.